Welcome, ladies and gentlemen. We have a little change in the program. It's still is Loop Energy, the company, but we have another almost had said referent. No, it's a speaker. It's not a referent. The referent, he's the marketing director of Loop Energy, and he's not from Italy like Luigi Fusi. It's Ethan, Ethan from Vancouver, Canada. Give him an applause.
Thank you. Hi, everyone. Yeah, thank you for having me. Whoop. Let me get that. So it's an honor to be here today, and thank you for the kind introduction. Yeah, as he said, I'm from Loop Energy. My name is Ethan, and I'm the marketing director for the company. Now, what I'm here to talk about here today is what does the demand mean when it increases for the development of fuel cell technology? I'm just going to skip through this legal slide. So before I go into that topic, I just want to give you guys a really quick run over of what our company does. I promise I won't be too salesy about this. We are a hydrogen fuel cell manufacturer. We're based in Vancouver, Canada. We have offices in North America, Europe, and Asia right now. And what you're looking at here are, well, pictures of our 30 kilowatt, 50 kilowatt, and 60 kilowatt module. We are founded in 2000, the year 2000, in BC. But we really stayed as an R&D and incubation company until about 2 years ago when we decided it was time to commercialize. So we went public in February last year on the Toronto Stock Exchange, where we raised our 100 million Canadian dollars, enough to hire me. So I joined in April of last year. But in all seriousness, these products are now on the road. We have over 500,000 kilometers in customers using our fuel cells already in the past year and a half. We're primarily focused in the commercial mobility, so buses and trucks, and some stationary applications as well, in places where the grid may not necessarily be there or be able to support it. So EV charging stations, mines, construction sites, airports, etc. So now let's talk about hydrogen and the demand and why it's going to soar, just to set the baseline of the story. So I'm going to walk over here for a sec. So firstly, we have the rising climate and environmental concerns. You guys know that. I'm not going to talk more about that. Secondly, we have electric powertrain delivering better performance. Now, this is important because EVs, even if you think about passenger cars, they actually deliver a better driving experience in many, many ways, right? And that's part of what is needed for any commercial adoption to be successful. So that is definitely one of the drivers of why hydrogen is soaring. Thirdly, increasing economic and regulatory shift away from diesel, so all the incentives and rules that are coming in for 2030 and 2050. Hydrogen is the most viable solution for commercial applications, right? Because batteries alone cannot make trucks and buses viable as an adoption method. So hydrogen comes in as a pathway to electrify commercial vehicles. And lastly, this is a new but really increasing reason for the demand for hydrogen. It's the rising concern for energy security. You guys have seen the news. I'm going to skip through that one too. Now, from some of our reports that we've seen out there, commercial fuel cell applications will grow to a 50 billion plus USD total addressable market, with a lot of it in the trucks and buses sector. Just to give you an example, I'm from Vancouver, Canada, so forgive my North American example here, but in Canada and US, transportation is 27 to 29% of the total global emissions in the GHG emissions in those countries. And of those, 84% are transportation emissions. So when we think about conversion and to electrify, road transport is particularly important to address. Now, what this means with this giant addressable market out there is we need better performing and cost-effective hydrogen fuel cell solutions. Not all hydrogen fuel cell solutions are made the same. Not all fuel cells are designed the same way. We have to make them better performing and cost-effective for commercial adoption. Otherwise, we're just a storytelling project. So let's discuss how we can transition to electrify from diesel to hydrogen fuel cell electric. So there are 5 factors to consider here. Why diesel has been successful and continued to be successful up until today, and hopefully not much longer, are 5 things. 1, the range and payload. 2, not so much the cleanness, but so far nobody's been able to beat the other 4 factors. 3, the fuel cost of diesel. 4, the power and energy density that comes from it as well. And 5, diesel is just simply more robust. So what does that mean, right, for hydrogen fuel cell adoption? It's really to address the 3 areas that we can improve on, right? Because we're definitely the clean option to move away from diesel. With hydrogen fuel cells, we're able to electrify and meet the range and payload where batteries alone probably cannot in most cases. So where fuel cell technology needs to continue to do R&D and innovation on are the last 3 factors here. Lower the fuel cost, increase the power density, and continue to increase the robustness of our products. So going back to Loop Energy a little bit, in addressing those 3 factors that I just talked about, we actually went to our bipolar plate and redesigned so that the channels are tapering in nature, as opposed to parallel. So what you'll see is that's a simplified version of our bipolar plate, but it's tapered and all the channels are narrowing as they go down the active area. We make that into the fuel cell stack, we put that into the fuel cell module, and we even put it into a system for those that need it. So it would be a module with a cooling system and DC-DC, all integrated with a fuel cell control system that we're able to control from the unit itself. So even the VCU, the vehicle control unit, does not need so much integration work. Now, thinking back to those 3 factors that I mentioned in 2 slides ago, with that design, which we have over 30 patents for at this point, we're able to deliver up to 16% better fuel efficiency compared to the industry average as a result of that design. We're able to deliver up to 90% higher peak power, and also we're able to deliver 10 times better current density uniformity. So let me just explain this last one a little bit. Conventionally, the plates are parallel in nature, as I mentioned, right? So what happens is the catalyst degradation is very high at the top of the active area of the plate. And as you go down the active area of the plate, what happens is you're not using as much of the catalyst, but instead you're having water accumulation. This is an issue because once you have flooding, you have to shut down, flush, and restart. Whereas with our design, we're also able to eliminate that problem. And that's a significant issue when it comes to commercial adoption. You don't want buses and trucks out there to have to deal with this issue. So as I mentioned, we're able to deliver on those 3 factors, and we have to, all fuel cell manufacturers, regardless Loop or not, have to continue to do so if we want to eliminate the world from diesel and move away from that. Just to give you a really quick example, not going to run through all the numbers here for the sake of time, but in a typical bus scenario, I'm giving a scenario of one bus driving around 500 kilometers per day and assuming a 17-year lifespan of that bus. And what happens if we have that 16% better fuel efficiency that I was talking about? With the consumption of 2.3 tons less hydrogen per year per bus because of that 16%, if we think about it from a cost factor, we're able to save $23,000 US per year per bus. And over 17 years, that's over $400,000, right? Just on innovation of the fuel cost alone. On the other hand, if we don't think about it, and we think about it as putting more range instead with that 16% into the bus itself and using it longer, we're able to deliver up to 30,000 kilometers per year per bus extra on top with that 16% fuel efficiency. That's close to 500,000 kilometers of the lifetime of that one bus alone, let alone multiplying that by the number of buses in your fleet. So you can think about that in all contexts, whether it's also, your trucks, your stationary applications. I'm just giving you one example of how effective you can be with innovation of fuel cells. So all science, all talk, I have to tell you, our customers out there are seeing the same things, right? They actually care about it. So with the 500,000 kilometers of in use around the world right now with our fuel cells, with different vehicles, we're seeing customers, this is a UK-based truck manufacturer, that is a China-based fleet of buses, and Korea and Slovakia as well. They're all talking about how cost performance and fuel efficiency is the biggest driving factor for their cost and considerations of fuel cells. Now, just a slight other thing, integration is very important. Oh, give me one more
interruption.
Give me one more minute. I'll just wrap it up really quickly here. So with vehicles, we need to scale, right? With hydrogen fuel cells. 4 things we need to consider. 1, production and supply. 2, production and supply. 2, the performance and TCO superiority, the total cost of ownership. 3rd is to make it as easy to adopt as possible. There's a plug-and-play solution. And 4, to provide the integration expertise that we can provide with our customers. Thank you.
Thanks a lot, Ethan Hugh. Give him an applause. I really appreciated just listening to you and to your way of speaking. I could listen for longer, even though I have a few other things to do here. Yeah. But if you want to see him, he's on booth C73, right?
Just over there. Just in the corner over there, yeah. Thank you, guys.